Alright, today we are going to continue talking about operations with rational expressions. Today we're going to be adding and subtracting. Alright, so to add and subtract rational expressions with the same denominator, life is easy. All you do is combine like terms in the numerator, place it over the common denominator, factor if you can, cancel if you can, and what's left is your answer. So, the denominators match, and the rule says when your denominators match, you keep that denominator, and you basically do the math on top, which says this minus this. So, I would have 5x plus 1 minus 4x minus 2 on top. So, if I clean up the top, distribute the negative, I'm going to have 5x plus 1 minus, I don't need parentheses, nothing's crawling there. So nothing distributes here. Distribute the negative is going to be minus 4x plus 2 all over x squared minus 9. Combine like terms on top. So I can combine the 5x minus 4x, which would be x. Positive 1 plus 2 would be 3. And on bottom, I can factor this. That would be bino, plus and mino. The square root of x squared is x. The square root of 9 is 3. So it's x plus 3 over x minus 3. And then I can cancel the x plus 3's, which leaves 1, because x plus 3 divided by itself is not nothing, it's 1. So my final answer is 1 over x minus 3. And that would be my answer. Okay, and they're not asking me to worry about domain and anything like that yet. So, alright, so you do this one, hit pause, come back when you're ready, and hopefully you got 3. If not, let's look at why. My denominators match, so I can keep the denominator and do the math on top, which says this polynomial, x squared minus 2x plus x squared plus x. So now if I clean it up, distribute a positive, I get x squared minus 2x plus x squared plus x all over x squared plus 7x. So if I combine like terms on top, I have 2x squared minus 2x plus x is minus x, and on bottom I have x squared plus 7x. So we've added them. Now we need to factor the top and the bottom and see if anything cancels. Two terms is easy to factor, GCF times what's left. I can factor out an x, which would leave 2x minus 1. On bottom I can factor out an x, which would leave x plus 7. And you can see the only like factors are the two monomials, so those would cancel, and I'm left with 2x minus 1 over x plus 7. Alright, try this one, hit pause, come back when you're ready, and hopefully you got 3. If not, let's look at why. The denominators match, so I'm going to keep that denominator, x squared plus 13x plus 40. And then I can combine the tops, this minus this, so I have 4x plus 2 minus 3x minus 6. Distribute on top and combine like terms. Nothing crawls, the negative crawls, so I have 4x plus 2 minus 3x plus 6 all over x squared plus 13x plus 40. On top, combine like terms. I have 4x minus 3x is x. 2 plus 6 is 8. On bottom, this should be an easy factor because a is 1. So x times x is x squared. Factors of 40 that would make 13 would be 5 and 8. Since c is positive, they both get the middle sign. And so I factor the top and the bottom. I can cancel the x plus 8's, which leaves 1 over x plus 5. Okay? Alright, so how do you add and subtract rational expressions? Well, if the denominators match, then you keep denominator, and add or subtract numerators. Simplify the top. Then you're going to factor the top, factor the bottom, cancel like factors, and you're done. Simplify. So if the denominators are the same, 1, you keep the denominator and add or subtract the numerators. 2, simplify the top, factor the bottom, cancel like factors, simplify, and you're done. That's if the denominators match. Okay? What if the denominators don't match? Well, you have to find the least common denominator, and to do that, you're going to want to factor each denominator completely, list all the factors of the first denominator, and then add to that list in step 2 any factors of the second denominator that don't appear in the list. Form the product of factors from the list in step 3. That will be the least common denominator. So then, after you find it, you're going to rewrite each rational expression as an equivalent expression whose denominator is the LCD. And to do that, you multiply the top and the bottom by any factors that are missing. Then we're back to what we did. Keep the denominator and add or subtract the numerators. Okay, so to do this, we need to look at my denominators, and I want to see if I can factor any of them, and I can't. Okay, they're degree 1s, they have nothing in common, so I can't factor them, which means my common denominator, let me rewrite this, x plus 2 over 2x minus 3. Actually, let me scoot over a little bit. X plus 2 over 2x minus 3 minus 4 over x plus 3. So, what I want is, I'm going to make a list. My first denominator has a 2x minus 3. My second denominator has an x plus 3. So, my LCD is going to be 2x minus 3 times x plus 3. So I need to make each of these denominators look like this. So that's easy. This one has the 2x minus 3. It's missing the x plus 3. So multiply the bottom by it. But if you do it to the bottom, you have to do it to the top. The second denominator has the x plus 3. It's missing the 2x minus 3. So I'm going to multiply by it, and now it has it. But if I do it to the bottom, I have to do it to the top. And now do you see they're in the different order, but do the two denominators have the same two factors in it? And yes, they do. So that's my common denominator, x plus 3 times 2x minus 3. Because now I can keep it since they match. You keep that and you do this math on top. So over here I'm going to have, let me keep my color straight here, x times x is x squared. That's going to be 2x. That's going to be 3x. 3 times 2 is 6. Now, here's where you got to be real careful when it's minus. Whatever you're subtracting, you better put in parentheses because you're going to have to distribute that negative. So, if I distribute, I get 4 times 2x is 8x. 4 times negative 3 is negative 12. So, I'm going to clean this up. I'm going to combine like terms and distribute my negative. So I have x squared plus 5x plus 6 minus 8x plus 12 all over x plus 3 times 2x minus 3. So now on top I'm going to combine like terms, and that's going to give me x squared minus 3x plus 18 over x plus 3 times 2x minus 3. So we've done the adding, or in this case the subtracting. Now we just have to factor the top and see if they cancel with anything on the bottom. The top should be an easy factor. A is 1, so x times x is x squared. Factors of 18 that'll make 3 would be 6 and 3. Since C is positive, they both will get the minus. And on bottom we have x minus 3, or x plus 3, sorry. Oh, wait a second. That doesn't work. I get the plus 18, but in the middle that's going to give me a negative 9x. Oh, let's think about this. Did I screw something up? No. 8x, that would be negative 8x, and that would be positive 12. Okay, so let's try and factor again. Factors of 18. 1 and 18 won't make 3. 2 and 9 won't make 3. 3 and 6 do, but only if I subtract. And C says I need an adding pair, so that doesn't work. 4 doesn't go in, 5 doesn't go in, 6 and 3. There's no way I can make 3, not with that being positive. So you can't factor the top, which means my answer is x squared minus 3x plus 18 over x plus 3 times 2x minus 3. Yeah? Alright, so that would be my final answer. Alright, so this one, if you look at the denominators, okay, they almost match. It's just that this guy's backwards from this one. And I can't, I could switch the order on this. I could write 11 over x minus 6 minus 3 over, I can switch the order, but it's going to be, that would be a negative x plus 6. They still don't match. The signs are wrong. It's called the -1 trick. And what you do is this. Alright, if I want to rewrite this, but I want to change their signs, I can factor out. Look, if I take 6 minus x, and I GCF times what's left, they have nothing in common, but you can always pull a 1. And since x is negative, I don't want it to be, I'm going to pull a -1. If I divide by -1, I get negative 6 plus x, and that is this. That is this, yes? So now I can rewrite, I have 11 over x minus 6 minus 3 over, I'm going to rewrite this as -1 times x minus 6. I can rewrite this as positive x minus 6. Like I said, I can switch the order. And now I switch the order and the signs. Okay? So now they almost have a common denominator. They both have the x minus 6. This one is just, so if I make my list, I need an x minus 6 factor and I need a -1 factor. I don't need 2 x minus 6's. The only way you'd need 2 is if one of your denominators had 2. So there's my list. This one has the x minus 6, it's missing the -1, so I got to do the top and the bottom by -1. This one has everything in the list, so I don't need to multiply by anything. And now you can see that my denominators match. So I'm going to keep that denominator, -1 times x minus 6, and on top I have -11 minus 3. So on top I'd have -14, and on bottom I'd have a -1 times x minus 6. And I can cancel the negatives, because a negative divided by a negative is a positive, which makes my answer 14 over x minus 6. Okay, that's called the -1 trick. Alright, so you do this one, hit pause, come back when you're ready, and you should get 2. If not, let's look at why. I can't factor anything, so I'm ready to make my list. My first denominator has an x in it, so I need an x. My second denominator has an x minus 7, so I need an x minus 7. So if I look at what's missing, this one has the x, but it's missing the x minus 7, so I'm going to multiply the top and the bottom by that. My second one has the x minus 7, he's missing the x, so multiply by x, and on top also. And now we have the same denominator, so I can keep the denominator, which is an x minus 7 times an x. So I'm keeping the denominator, and I'm going to do the math on top, which is going to give me 2x minus 14 plus 9x. Okay, and I'm skipping a few steps. I'm not writing every little thing out. Okay, I will if you need me to, but combine like terms. That's going to give me 9, 10, 11x minus 14 over x times x minus 7. And the order you put this in doesn't matter. The only thing left I could try and do would be to factor the top and see if it cancels with the factor on bottom, but 11's prime, they have nothing in common, I can't factor, so I'm done. Okay? Alright, you try this one, it's the -1 trick, see how you do, hit pause, come back when you're ready, and you should get number 4. If you did not, okay, I'm going to take this denominator and I'm going to try and make it look like this, because it does, except for it's backwards. So if I take 9 minus x, and I've GCF by -1, that would give me -9 plus x. And I can rewrite, change the order of this, positive x minus 9. So I'm going to rewrite my first denominator, or my second denominator, as -1 times x minus 9. So now, when I make my list, my first denominator has an x minus 9, and so does my second one, so that's okay, one will do both. Okay, and in my second denominator, there's also a -1. So my common denominator is going to be both of those. This one has the x minus 9, he's missing the -1, so I got to multiply the top and the bottom by -1. Now they look alike, so my denominator is -1 times x minus 9, and on top I have -11 plus 22. Subtract on top, I get positive 11 over -1 times x minus 9. And then all they did, instead of writing the -1 on the bottom, is they said, well, a positive divided by a negative is going to make the whole thing negative. And that's how they ended up with that. Okay? Alright. So now it's going to just, same kind of deal, it's just going to get a little bit more complicated. I don't want to make my list right now because these are not in factored form. You can, but it ain't going to be fun trying to multiply by trinomials and difference of squares. It's going to make things huge to simplify later. So you're better off to factor first and get your least common denominator. So if I factor this, it should be an easy factor, x and x. Factors of 2 that make 1 are 1 and 2. C is negative, so only the bully gets the plus, he gets the minus. So I can rewrite that fraction as x plus 3 over x minus 1 times x plus 2. Okay, my second fraction, I can factor the bottom. That's difference of squares. Bino, plus n, mino. Square root of x squared is x. Square root of 1 is 1. So I can rewrite my second fraction as 2 over x plus 1 times x minus 1. So now that everything is factored, I can go ahead and make my list. In my first denominator, I see an x minus 1 and an x plus 2. That'll take care of this, and this. Okay? And the only other thing that won't be taken care of then is that x plus 1. So in my list, I also need to add an x plus 1. I've got everything colored and covered. Okay, so my common denominator needs to have all of these 3 in it. This one is missing the x plus 1. So I have to multiply the top and the bottom by x plus 1. This one has the x minus 1, the x plus 1. It's missing the x plus 2. So I'm going to multiply the top and the bottom by x plus 2. And now you can see, although I've written them in a different order, oh no I haven't, they're not the same. Do my denominators have all of the same factors in them? And yes, they do. So I'm going to keep that denominator, which is x plus 1, x minus 1, x plus 2. And I'm going to simplify on top. On top, I'm going to distribute. That's going to give me, let me see, a different color. X times x is x squared. X times 3 is 3x. 1 times x is x. 1 times 3 is 3. If I simplify the second one, distribute, I get a positive 2x plus 4. The only time you have to worry about parentheses and all that is if that was a minus. Okay? So now I'm going to clean up the top, combine like terms. I've got x squared. 3x plus x is 4x, plus 2x is 6x, and 3 plus 4 is 7, all over x plus 1 times x minus 1 times x plus 2. And the adding is done, but I have to see if I can factor the top and cancel it with any factors on the bottom. So if I try and find factors of 7 that make 6, factors of 7 are 1 and 7, which will make 6 if I subtract. However, C says I have to add. And there's no way I can add a 1 and a 7 and get 6. So I can't factor, which means I am done. Okay? Alright. Now we've got 3 rational expressions that we're trying to add and subtract. Again, these 2 factors are factored. So, are prime. I can't factor them anymore. This I should be able to factor. And it should be an easy factor since a is 1. So x times x is x squared. Factors of 2 that make 3 are 1 and 2. C is positive, so they both get the middle. So I can rewrite this as 4x squared plus x minus 6 over x plus 2 times x plus 1. Nothing else can be factored, so minus 3x. And if you're asking, why don't I factor the top, this trinomial, you could, but until I get a common denominator and combine like terms, you just have to FOIL it back out, so don't bother. Alright, so now I can make my list. And in my list, my first fraction has an x plus 2 and an x plus 1. So that'll take care of these 2 plus that one plus that one. Okay, so I've got everything colored and covered. So if I rewrite now, this one's missing nothing. It's got both of everything in my list. This one has the x plus 1. He's missing the x plus 2. So I'm going to have to multiply by x plus 2. This guy has the x plus 2. He's missing the x plus 1. So top and bottom by x plus 1. And now you can see that all 3 of my denominators have the exact same factors in it, which means they now match, which means I can now keep it. The denominator is going to be x plus 2 times x plus 1. And I simplify. On top, we didn't have to multiply by anything, so that's going to be 4x squared plus x minus 6. The second one, I'm going to distribute, and I'm going to get negative 3x squared, negative 6x. And on the third one, I'm going to distribute, because I'm distributing the negative, I'm skipping a step. Instead of doing minus in the parentheses and then distributing, I'm just distributing negative 3x. I'm distributing the negative at the same time that I distribute the 3x. If I distribute a positive 5, I get positive 5x plus 5. Okay, so now if I combine like terms, 4x squared minus 3x squared is 1x squared. Positive x minus 6x would be negative 5x, plus 5x would cancel out. And I would have negative 6 plus 5 is negative 1. On bottom, I'd still have my x plus 2 times my x plus 1. And the adding and subtracting is done. The only thing I could still possibly do is factor the top and see if it cancels. And I can factor the top because that's difference of squares. So bino, plus n, mino. The square root of x squared is x. The square root of 1 is 1. And the bottom is x plus 2 times x plus 1. And sure enough, I have like factors. They cancel. And so I'm left with x minus 1 over x plus 2. Okay, that is fun. Alright, so you try this one. Hit pause, come back when you're ready. And I hope you got number 4. If you did not, let's look at y. Alright, before I try and make a list, I want to factor if I can. This one should be an easy factor, because a is 1. So x and x, factors of 28 that make 11 would be 7 and 4. C is positive, so they both get the middle. So that's going to give me x plus 5 over x plus 7 times x plus 4. If I factor the bottom of my second fraction, again, it should be an easy factor. X times x is x squared. Factors of 21 that make 10 would be 3 and 7. Since c is positive, they both get the middle, so I can rewrite that as 2x plus 1 over x plus 3 times x plus 7. So now that everything is factored, I can make my list. And in my list, I need an x plus 7, which will take care of that and that. I need an x plus 4, and I need an x plus 3. So this one has the x plus 7 and the x plus 4. So the right side. This side has the x plus 7 and the x plus 4. I need the x plus 3. So I'm going to multiply the top and the bottom by x plus 3. On the second fraction, it has the x plus 3 and the x plus 7. It's missing the x plus 4. So bottom and top by x plus 4. So now do you see that my two fractions have the exact same 3 factors in them? So that's going to be my common denominator, which I will keep as x plus 3, x plus 7, x plus 4. On top here, a different color. X times x is x squared. X times 5 is 5x. 3 times x is 3x. 3 times 5 is 15. Because it's a plus, I don't have to worry about distributing a negative. So 2x times x is positive 2x squared. 2x times 4 is positive 8x. 1 times x is x. 1 times 4 is 4. So now on top, I'm going to combine like terms. X squared plus 2x squared is 3x squared. 5x plus 3x is 8x, plus 8x is 16x, plus x is 17x. And 15 plus 4 is 19, all over x plus 3 times x plus 7 times x plus 4. And again, we're done, but the only reason I know that is because the answer's staring at me and I have the check mark there. Remember, you should try and factor and cancel. But if I do 3 times 19, I get 10 times 19, I get 57. Factors of 57. 1 and 57 will not make 17. 57 divided by 2 is a decimal. Divided by 3 is 19. I could make 16 if I subtracted, or 22 if I added. Nope, I need 17. That didn't work. 57 divided by 4 is a decimal. 57 divided by 5 is a decimal. 57 divided by 6 is a decimal. 57 divided by 7 is a decimal. 57 divided by 8 is a decimal. 57 divided by 9 is a decimal. 57 divided by 10 is a decimal. By 11 is a decimal. By 12 is a decimal. I don't think I'm finding anything else. So we can't make b, which means it's prime, which means I'm done. Alright, let me try this one. Hit pause, come back when you're ready. And hopefully you got 3. Alright, this is done. I can't factor. I can't factor this. I can. That's going to be x plus 1, x minus 1, difference of squares. So if I make my list, I need to rewrite this because it's not going to fit. So I got 4x over x plus 1 plus 5 over x minus 1 minus 8 over x plus 1 times x minus 1. If I make my list, my first fraction, my first denominator, has an x plus 1, so I need that in my list, and that'll take care of that one and that one. My second fraction has an x minus 1 on bottom, and that'll take care of this one and this one. So there's my LCD. This one has the x plus 1, it's missing the x minus 1, so top and bottom by x minus 1. The second one has the x minus 1, it's missing its x plus 1. And the last one is missing nothing. It has everything in the list, so I don't need to multiply top and bottom by anything. And now you can see that all three denominators match. Again, I might write them in a different order, but if they have the same factors, it's the same denominator. So I'm going to keep that. Keep that denominator, which is going to be x minus 1 times x plus 1, and I'm going to simplify the tops. Distribute, I get 4x squared minus 4x. Distribute the 5 in the middle, I get plus 5x plus 5. And I don't have to multiply the top of the other one by anything, so just bring down minus 8. So now we're going to clean up the top and then try and factor and reduce. On top, I have 4x squared. Negative 4x plus 5x is x. 5 minus 8 is negative 3. All over x minus 1 times x plus 1. That answer isn't there because clearly I need to factor the top, which is not going to be an easy factor because a isn't 1. So I have 4x squared, and we'll go over to the side. And we have to do a times c, find all the factors, rewrite b, 2 by 2, GCF, GCF, GCF again. Woo! So 4 times 3 is 12. Factors of 12 that make 1 would be 4 and 3. C is negative, so only the bully gets the middle. So I'm going to rewrite x as positive 4x minus 3. Everything else comes down, the 4x squared in front, the minus 3 at the back. And now we are at 2 by 2, GCF, GCF, GCF again. Woo. On the left I can factor out a 4x, which would leave x plus 1. On the right, I can factor out a negative 3, which would leave positive x plus 1. GCF again by the x plus 1 leaves 4x minus 3. So on top, I can rewrite that as x plus 1 times 4x minus 3 over x minus 1 times x plus 1. The x plus 1's cancel, and I'm left with 4x minus 3 over x minus 1. Okay? Alright. And there you go. So how do you add and subtract rational expressions? I know we answered it, but that was when the denominators were the same. When you have different denominators, 1, factor all denominators. 2, list all factors in all denominators. Don't repeat unless you have to. Okay, so then you're going to get a least common denominator. Rewrite your fractions. Rewrite the problem with the LCD. And then simplify the top. Simplify and factor the top. Cancel like factors. And simplify again. Okay. Alright, and we are at homework, so we are done. Happy homeworking, and I will see you next time.